This is episode 4 in a series chronicling my adventures in building a DIY CNC router. If you missed the previous episodes, I encourage you to go back and check them out. There's a lot packed into this episode, so let's get to it. Let's give it a try. It's time to start working on the Y-roller assemblies. The wiki says I'll need the number 4, number 5 drill guides, so I'll get those cooking on the 3D printer. I started by marking the front and back as well as the top and bottom of the pieces of steel just to keep everything consistent moving forward. Then, using the drill guides and the procedure illustrated many times in this series already, I laid out the holes with a transfer punch and reinforced those marks with a center punch. As in previous videos in this series, I'm using a piece of 3/8" plate to serve as a base to punch on. I feel it possibly gave me a bit more defined punch mark, or it could be the open container of acetone talking. I'll spare you the shots of me drilling and tapping the holes, but for reference, the bottom 4 holes are drilled to 6.5 millimeters because I'm using W20 bearing blocks. The top holes are drilled to 5 millimeters and tapped for M6. There's definitely phalange gymnastics involved with getting these bearing blocks mounted. I would highly recommend deburring and rounding over the inside edge of the tube cuts to save wear and literal tear on the fingers. I'm not making these fasteners super tight at this point, since I'm sure there will be plenty of adjustment necessary in the near future. Each bearing block comes with a plastic retainer to keep the bearings from falling out. To mount the block on the rail, simply line up the groove with the rail and slide it on, allowing the retainer to be pushed out the back until the block is fully seated. Hang on to that plastic retainer in case the block needs to be removed, which it will. With the Y-roller assembly installed on the rail, the BKHM risers are loosely installed on each rail. Since I'm working on the rollers, I decided to knock out the X-roller as well. Checking the wiki and verifying with the Fusion model, I'll need the 8A and 8B drill guides, so I ran those through the printing process. As with the Y-rollers, I marked the tube for consistency, realizing a marking of left to right would make more sense than front to back. If there's one skill I'll really be good at by the time this project is over, it's transfer punching. I first marked out the top and bottom hole locations. Next task was to transfer the locations for mounting the Z-plate. The Fusion model shows to use the drill guide on the left side of the tube. Again, because my build is using W20 bearing blocks, the top and bottom holes are drilled to 6.5 millimeters. The holes for mounting the Z-plate are drilled to 5 millimeters and tapped for M6. This is where things start to get a bit freeform. The current version 4 wiki seems to be far from complete, and when I started this build, I was using part of the now labeled as obsolete version 3 of the wiki. The problem is, none of what I'm about to show is in version 4 of the wiki. So this is where relying on the Fusion model for guidance really takes over. I did manage to find the old version 3 wiki, and I'll leave a link to that in the description below, but it should be used for general guidance only, as quite a bit has changed in the PrintNC version 4. All that being said, let's move on. Fitting the Y-axis ball screw starts by mounting the BF bearing blocks on the rear of the two Y rails. As with everything else, I'm only making things finger tight, as everything will need to be aligned. The ball screw was fed through the Y roller tube and inserted into the BF bearing. It should be a very exact fit, so don't force it. With the BF end inserted and still holding on to the front end of the ball screw so it doesn't bend, slide on the BKHM bearing block. Pay attention to the orientation of the block so the bearing carrier is facing the back. Also note that there are bushings which set the depth of both the screw side as well as the nut side. These fall out easily, so if they're not in their proper places, hunt around for them. Also note, they're different sizes. Here I switched them around so the shorter bushing is in the back, allowing just enough give for the fastener holes to line up. As with everything else, I'm only making things tight enough to hold together at this point. Finally, the retaining nut is installed. Again, note the orientation. There is a machined flat that engages against the bushing. Just finger tight for now, and I'm not tightening the grub screw. With both Y-axis ball screws installed, they should spin freely. If there's any binding, scraping, or dragging, loosen the mounting hardware and get things aligned properly. Now it's time to work on attaching the ball screw to the Y roller itself. Back in Fusion, I see that I need 2 copies each of the 1610 nut plate as well as the 1610 fill plate, 1610 being the specification of the ball screw I'm using. Send to print. These plates are held together using 135mm M5 threaded rods and nuts, 6 per side. I ordered 300mm stainless steel M5 threaded rods from McMaster-Carr with the idea I would cut them to size myself. In order to speed things up and make the cuts fairly consistent in length, I modeled up a quick tool in Fusion that would serve 3 purposes: consistent 135mm length, a handle to hold the rod, and hand protection from the heat generated by cutting. I used an angle grinder mounted in a vise with a cutoff wheel installed to quickly knock out the 135mm rods. If these were a few millimeters over, it won't matter. Longer is better than short in this instance. I touched up the ends on a grinding wheel to make starting the nuts a bit easier. I fitted the rods into the nut plate first. Interestingly, the nut plate prints with threads. I found them to be a bit problematic, read that, tight, so I used the tapping machine off camera to open up the holes just slightly. I threaded the backside nuts on and installed the plate and rods into the ball screw bearing. Because this stuff is printed in plastic, there's a bit of give and play. Not the nice fit of machined aluminum or steel. I can see why people make these parts out of aluminum once the CNC machine is up and running, but this should suffice for now. Next, I installed the fill plate on the back to make sure the rods were adjusted correctly to give enough purchase for the nuts on both ends. Satisfied with the fit, I tightened down the front and back nuts on the ball screw bearing, then installed the fill plate and the corresponding nuts. This is where having the two faces of the tube being as parallel in all directions as possible comes into play. If the faces are out of alignment, the entire roller tube will be pulled out of alignment with the rail and bind. As with everything else in this build, the more attention to detail you give it, the better the final product will be. With everything put together, the screw turns relatively easily. I honestly don't know how much resistance there should be when pushing the Y-roller back and forth, but it should at least be consistent through the entire travel of the screw. Also, I've not lubricated anything yet, so that should make a difference. As a final note, don't be too aggressive with moving the roller back and forth until proper lubrication has been applied with the bearing block and the ball screw bearings. Just move it enough to test for consistent resistance. Switching to the X-axis in the gantry, the Fusion file tells me I need drill guides 7A and 7B, as well as some rail centering guides which I can reuse from the Y-axis assembly. I also need a BF and BKHM riser, so I'll get those printing. Next, I need to make some allowances for the parts mismatch issue, which I outlined in previous episodes. Last episode I dealt with this issue on the Y-axis. Now I have to deal with it on the X. For the gantry, the Fusion model says I should have 1150mm linear rails and 1250mm ball screws. Looking at the manifest from the hardware package, I received 1200mm rails and 1300mm ball screws. Now the difference is 5 centimeters or about 2 inches. That doesn't seem like a lot, but remember, when putting this thing together, we're splitting millimeters for accuracy. Fortunately, the gantry is long enough to accommodate the longer ball screw because that can't be cut. I can use the full 1250mm rail on top, it just sets the mounts further out than specified in the wiki and the Fusion file. The main thing will be to set the stop appropriately for the spindle assembly so it can't use the extra travel and crash into the Y-axis rail, but we're a long way from that. So, putting the BKHM riser at the very end of the tube as shown in the Fusion model, I used the rail and ball screw as the measurement for the BF riser placement. With those marked out and transfer punched, I drilled to 5mm and tapped for M6. The bottom rail will need to be cut so it doesn't interfere with the Y roller. I measured in from the end the same amount as the top rail and scribed a line. Then I measured from that line 1150mm and scribed another line. I then marked the rail for cutoff. I admit to kind of eyeballing this measurement, but the truth is the exact length isn't critical as long as it's short enough to not hit the Y roller and long enough to complete the full travel of the Z-axis. It occurred to me that it would be really critical that the top and bottom rails are bisected by the same plane and their center lines are collinear as much as possible. So I took some measurements to verify the guides actually do center the rail. From what I could tell, it appeared to be quite close, so I decided to go with it. I marked each end of the rail using my trusty 5/64 transfer punch. And then drilled the 2 holes to 4 mm and tapped for M5. I then installed the first fastener, applied the centering guides, then installed the fastener at the other end, making certain the holes lined up exactly. With the rail held firmly in place, I proceeded to transfer punch the remaining 17 locations. Center drilled to 4 mm, and tapped to M5, all the while using my favorite Anchor Lube cutting lubricant. With all 19 holes done, I did a final check to make certain all the fasteners could be driven home. Moving on to the top rail, I installed the BKHM riser to use as a guide and repeated the process. First drilling and tapping the 2 ends to act as anchors, then completing the 18 other holes. By this point, summer on the lake had rolled around, so I took a little time off. Well, I don't know about you, but I can only watch so many holes being tapped in one sitting. Things are moving along, and next episode we'll be mounting the gantry and finishing up with the major construction. Thank you to everyone who's commented on the series so far. It's fun and inspiring to hear that you find it interesting. Please strike a like and subscribe if you haven't. It really helps with trying to grow the channel. Well, I'm going to go finish editing episode 5 for next week. Until then, I'm mainejason. Get out there and give it a try.